Hello everyone, in this video we will be solving a medium problem number 402, remove k digits. The problem statement is, given string num representing a non-negative number and an integer k, we need to return the smallest possible integer after we remove k digits from the num. If you look at example number 1, 1432219 and our k is set to 3. So to get the smallest possible integer, we remove 432 from the input, giving us the remaining numbers as 1219, which is the smallest possible that we can build. Let's switch to Whiteboard and talk about the different scenarios and identify how this can be solved. I will try to simplify this problem into smaller subproblems so that we can understand what are the necessary steps we need to think about when we are coming up with a solution. Let's say the number is 12345, and if I ask you to remove one character from this input to make it the smallest possible number, obviously the number that you will be removing is this one, because this one carries the maximum weight as it is in the left side of the number. This 5, because it is at the units place, it does not have the same value. I can simply say that as we are moving towards the right, the weight of the position decreases. Let's say our number is 373, and if I try to map it on a graph, it should look something like this. Now with this example, let's say my k is 1. Which number would you try to remove? Based on the previous example that we just talked about, if you remove 3, it should give you the minimum integer, but that is not the case. So if you remove 3, the result will be 73, which is smaller, but you can get even smaller if you remove 7. Then our output will be 33, which is smaller than 73. The logic to remove 7 is that the value 7 and the next value 3, there is a decrease. 7 is greater than 3. Hence, if we remove 7, we will get a result which is going to be lower. Anytime we see a value dipping down, we should be removing that number to get the minimum integer. Let's take another example to confirm this theory. Now in this example, the maximum is 5, but it is being repeated twice. And let's assume my k is still 1. We need to identify where the value of the digit is decreasing. So one is this dip from 5 to 2. Another is this dip from 5 and 3. So in this example, we have 2 dips. How to determine which number to remove to get the minimum value? In this scenario, the analysis that we did earlier, where the number to the left is going to have the maximum weight, and as we move to the right, its value is going to drop. So if we want to calculate or find out the minimum integer, we need to always start from the left hand side and try to update that or remove that digit to get the minimum value. So using that same rule in this example, with k is equal to 1, I should remove this integer, this 5 from the numbers. This is the minimum that we can build with k is equal to 1. If we were to remove the second 5, we would get 1, 5, 2, 3, which is not the minimum. If I were to have k is equal to 2 in this example, I would have removed 5 first. So I would get 1, 2, 5, 3, and then the next dip is between 5 and 3. So I would remove 5 and the result will be 1, 2, 3. For this implementation, what we are doing is, while we are iterating through the numbers from left to right, whenever we are pointing at a certain number, we are comparing it against the last value that we have calculated to find out if there is a dip, and if yes, then should we remove it or not depending on the value of k. the best data structure that supports this kind of an implementation where we need to look at the last value that was added or processed is stacks. So we will use stacks to come up with the implementation to solve this problem. Let's discuss how the previous analysis that we did can help us solve this problem. I will be using this stack which will hold the last value that we have processed. Starting with the first value, we will compare the digit with the last value that was added to the stack. Because there is no value, we cannot do anything about it. So I will add 1 to the stack and increment my pointer. So my new value is 5. Compare it to the last value that was added. Is 5 less than the last value? If 5 is less, it means there was a dip. But in this case, 5 is greater. There is no dip, so we cannot remove 1 yet. So I will add 5 to the stack. So I will have another value in the stack and increment my pointer. So now I am pointing at 2. So my current value is 2. The last value is now 5. Comparing 2 against 5, 2 is less than 5. It means the last value that was added was greater than the current value. So there is a dip, and with k greater than 0, we can still remove a certain digit. So we will remove 5 from the stack. After popping out 5 from the stack, we will be decrementing the value of k. So my new value for k is going to be 1. Once we pop out, there is also a possibility that the number that was inserted before 5 can be greater than the current value. We need to continue comparing until we confirm that 2 is greater than the previous value. So we will update the last value to 1, comparing 2 and 1. 2 is greater than 1. It means there is not a dip, it is an increment. We will add 2 to our stack. Increment our pointer, so we will now point to 5. New value is 5. My last value is 2. Comparing 5 and 2. 5 is greater than 2. It means it is not a dip. And if I put it on a graph, we will have something like this. So it is still incrementing. So we cannot remove it yet. My k remains the same. We will push 5 into the stack and increment our pointer. So now we are pointing at the last value, which is 3. Comparing 3 and the last value, which is 5. 3 is less than 5. It means there is a dip. And because my k is still not equal to 0, we can remove another digit. So we will pop the last value out, decrement our k. So the new value is going to be 0. There is no point of doing the comparison because our value of k is 0. If there are any more values after 3, we can just add it to the stack directly, and once the iteration is complete, we can build a new string with all of the values from the stack and return the result. So based on the values from the stack, this is going to be our result. With this solution, our time complexity is O of n, where n is the number of characters in the num input that is given to us, and our space complexity is O of n, as we are maintaining this stack with the numbers that we are pushing. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. So here is the C# solution. I start by initializing the stack which will hold the values that we are iterating. Then I start a while loop until the pointer I is less than nums.length. Then I extract the character that I is pointing at and convert it into integer. Then the next step is where I'm checking if my stack count is greater than 0 and k is also greater than 0. If the stack does not have any value, we cannot compare the current value that I is pointing at. So we will go under this else condition and push the current value to the stack and increment our pointer. If my stack count is equal to 0 and the temp value is also 0, there's no point of adding it because it will become a leading 0 and we don't need that. I have this empty if condition to avoid that scenario. In the if condition, I'm comparing if the temp value is less than the last value pushed to the stack. If that is true, it means there is a dip. So I'm popping out or removing the last value from the stack, decrementing my k. But if my temp value is equal to or greater than peak, then we can add the same value to the stack and increment our pointer. Once this while loop is complete or we are at end of the iteration, if my k is still greater than 0, this can be possible if all of the values in my input are the same. We will not see a dip. So for that scenario, we will run this while loop which will run until k is greater than 0 and try to remove the last value that was added to the stack. The next step is where we are building the result. So if my stack count is greater than 0, I am appending it to the result. My result will be empty. So I am setting result is equal to 0 just in case and then returning it. This is sort of an Thank you for watching this video. I hope you were able to understand my explanation and this source code. This source code is available on my GitHub repository. The link will be there in the description below. Feel free to check that out and I will see you in the next video. Till then, stay tuned and keep coding.